Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, welcome everybody. I'm Stuart Tansley in external research here in Microsoft Research, but I'm really here to introduce my friend and partner in robotics, Professor Robin Murphy, formerly at University of South Florida, but now at the Texas A&M University. She's here today to talk about emergency informatics and the Survivor Buddy project, which is a project that we're doing collaboratively, although in a very lightweight collaboration. But she's going to tell us all about that shortly. Okay, over to Robin.
Thank you, and howdy, as we say at Texas A&M. So I'm going to be talking about emergency informatics, which is a big thrust at Texas A&M, and then I'm going to scope it down to the area that I do within that, which is unmanned systems, in a particular project called the Survivor Buddy, which is how a robot can be your best friend during a disaster. So what is emergency informatics? Well, it's the real-time collection, processing, distribution, visualization of information for disaster or for an emergency incident. And that really consists of prevention, preparedness, response, and recovery. And so a lot of people think of it as just as when the incident happens, but the information before, after, during, all the structures that need to be put into place. So we're very interested in that. And of course, emergency informatics is different because the nature of emergencies are different. They're infrequent. People do them as exceptions, not as part of their day-to-day. Every emergency is different. And so even though we have course patterns, the things that you need to know at Hurricane Katrina were quite different than the things you need to know at World Trade Center. I was at the World Trade Center. Everybody was predicated off of the Northridge earthquake model of how they were going to respond to a disaster. And of course, that was a building collapse in a major urban area, and it didn't work that way. Even the structures were right. So many challenges with emergency informatics, and that's something that we work on at Texas A&M. Now, my area, I was just put in IEEE Spectrum for my dream job, which is I work in rescue robotics, and I've been doing that since 1995, and that backdrop is part of one of our sites at Disaster City, which I'll talk about a little bit later. 2001, research. What we've done since 2001, we've been in 10 different disasters, and then we've set through several others like Hurricane Dennis, where we've been in the EOC, watched all the deployments, and Dennis was sort of a non-starter. We've used unmanned aerial, ground, and surface or water, marine vehicles for these disasters. And we see the information flow as we go through it. So we have a lot of boots on the ground experience. And that's where I'm coming from. So this is a personal passion and motivation for me. One thing about Texas A&M, just to let you know about the engineering college, it's one of the top 10 engineering colleges in the world. We've got about 10,000 students, which puts us about the size. Our engineering college is the size of Georgia Tech. Texas A&M has 48,000 students there. Computer science is, again, a top program, ranked 15th, and we have 46 faculty. I was the 46th, and we have about 1,000 students. Now, let's talk about emergency informatics, and I think of it in terms of this idea of basic research, which is what we, computer scientists, mechanical engineers, industrial engineers, psychologists, all of us are really good at, but it's not necessarily, the fundamental advances are not particularly tied to a particular application. You think of emergencies, you need networks, right? Wireless networks are important. Security, unmanned systems, real-time distributed computing, cyber-physical systems, physical devices you can trust. Visualization and simulation is very important. How you use video games to train for this. Social networking. Almost all the applications now, people almost invariably assume to understand a disaster, it must be geolocative, that you must relate to the geography of it and see it on a map. That's not always true, but we tend to go that way. We have sensors and sensing, artificial intelligence, any intelligent decision aids in making that. And so we have this information space, and if you see, you have the prevention and preparedness phases before the incident happens. Then the incident happens, and we have response and recovery. And these, how do we get from here to there, to what we need? Well, the traditional method is policy-based, right? Where you have something like the federal government say, here's what we need, we're going to get people to build this, we'll contract with companies or places like MITRE or SIC to build up large systems, we'll give these to the responders, and the responders will deal with it. And we're very good at that at Texas A&M. We have a policy institute. We have a college on government service and policy, and the Policy Institute works particularly on how to get in, managers, city managers, different levels of the hierarchy to know what to ask for in technology, how to integrate, what's the impact on training, what's the impact on cost. We also have what's called TEAX, Texas Engineering Extension Service, which is the state agency for emergency response. Texas A&M actually owns Search and Rescue, Emergency Support Function 9 for the entire state of Texas. Texas is the size of 8 average states in the United States, so it's a huge deal there. And we also have, since the late 1800s, have trained firemen. We train fire rescue teams from all over the world. Secret Service are down there, law enforcement, FBI. So we have a good boots on the ground. We know this path, we know how to get it in there, we know how to train, we know how to use it ourselves, but it's lacking. Okay, and that's just Disaster City. We've got a 52-acre facility where we can try just about everything out there. Okay. Now, what's really fascinating to me, having been in several disasters, is that people spontaneously adopt abilities. Particularly, they go to this cloud, particularly with the idea of social networking. They put the wireless, they do ad hoc stuff. They build their own websites. They create new applications. They find data and mine it and put it out there. Hurricane Ike, we were looking at using our marine vehicle, our surface vehicle, to check out one of the bridges that had collapsed. When I pulled up Google Earth, people had already begun to mark hazards in the channel that they had encountered themselves because they have their own GPS system. Now, there's all these disclaimers that, the Army Corps of Engineers has not checked this out, but I'm thinking, these people also put pictures of the hazards with there too. And I'm thinking, yeah, the Army Corps of Engineers should quit putting disclaimers. They should embrace this, right? I understand there's problems. Right? And so what gets interesting, these are mostly, for me, what's fascinating, it's the victims who are doing the majority of the adopting and adapting in real time. Because as we see these types of interactions that we see, the traditional, take usually 7 years. The lag time, because it's requirements driven, it's very, very much that old waterfall style. We'll think of it, and of course we know our technology is changing faster than 18 months on the things that we can see and do. And what you'll also see is people in the emergency response community will kind of sneak it in. They'll start using their cell phones in creative ways. They'll call each other, they'll text. Unfortunately, because of the politics and bureaucracies being bureaucracies, you'll get cases like where they're told they can't bring their cell phones because they might leak information out to somebody who shouldn't know. And their wife may call them or husband may call them, and a lot of times they do. They call them with good information that we couldn't get any other way from CNN or something that they know, or they know something here. But we shut that down. So this confluence of how we take the wonder of basic research that we have here, get it in here, but at the same time take advantage of it in real time, see it, propagate it, get it to the right people within the recovery period, within that 72-hour, the crisis part of the response. Wouldn't that be great to have that, to do that? And that's what our global stuff, that's what we're working on. And we have 55 faculty members that are working in this area from 10 departments in 4 colleges. And so the questions that we are working on are this idea of polycentric control architecture. So it's no longer hierarchies. We've got horizontal, we've got vertical methods that we have relationships and we pass information and we make clusters of decisions here and we have a lot of emergent behavior. And that gives us adaptivity and resilience. How do we exploit that? How do we get the right information to the right people at the right time when our networks are bandwidth constrained? Every time you go to a technology exercise, something like the Strong Angels, if anybody does Strong Angels or that, and you go there and immediately saturates because everybody has all that. And then things go down intermittently and you have this. So we don't have that capacity. And all the solutions in AI have always been predicated on that you can do contract net protocols, that you can use more bandwidth to negotiate. And so we need to find ways that don't rely on that because it's making the problem worse, right? Talking about who's going to share is taking up more bandwidth on the bandwidth we're trying to share that we don't have enough of. Another area that's very important to us is visualization and simulation. And what we find is that we have these great models that you couldn't tell, that work sort of, but remember, every emergency is different in its own way. There's always something different. How can we correct, how can we update that model and simulation in real time? How do we get the information in there? How do we say, oh, no, go get us that information because we need to update this so the decision makers can run through and do some projections? How can we use this idea actively? Do it. Not only can we do it actively? And then an area that is very interesting to me personally is that we know that yellow branch where people are spontaneously coming up with good ideas, both within the organizations and within this larger group of the general population. How do we notice what's working well and get that replicated and get that out there and institutionalized or whatever we want to call it to get it to really to propagate the good stuff? How do we detect new adoption and adaptations of these technologies? And a lot of these technologies are information technology based, so we can, there should be ways to embed that in the way that we distribute the information itself. All right, well, that's what we do at Texas A&M. That's what we do at Texas A&M. I'm going to talk now, turn the attention to what I personally do. My area is unmanned systems. And I've already alluded to that this is a picture of Oklahoma City, but you can see that aerial vehicles to give views closer in here that you can't get from a manned helicopter, ground vehicles to go behind the rubble where it's not safe for people, not even physically possible for a person or a dog to get back in there. If this were near, Oklahoma is rare, but most of the population now lives near water. So you can imagine having marine vehicles to look at your bridges, your infrastructures at the World Trade Center, worried about that basement collapsing. Because if that had collapsed, it would have taken out several of the buildings.
So when you say unmanned, you don't mean autonomous, right?
It can be autonomous.
But it can also be controlled by a person.
Right. And another distinction is that in emergency response work, a lot of the unmanned systems work is not classically autonomous, even if it could be. The autonomy levels are there for the control, because in emergency response, you are trying to project yourself into the scene. You want that data in real time. And because everything's different, you personally want to see it so you can see the anomaly, the thing that you couldn't tell anybody else to look for because you don't know it until you see it. And so we see a focus of people saying in robotics, saying, oh, we want one person to control 100 robots at a site. Okay, that's a control idea. What I want to see is how do you have the network structure for 1,000 people to look through that robot and make sure they're seeing what they need to see in real time. I always get the data from these high-altitude autonomous things. We get it 2 weeks later. The governor, the president gets the data. but the streams don't go to the people in the field. And I do the boots on the ground. I've been in both places. I watch how it goes. Okay, so that's unmanned systems, generic term, autonomy. You're not going to see a lot of full autonomy in the systems I'm going to talk about because we need the human in the loop. The human wants to be in the loop. Okay. And in terms of unmanned systems, these are just some of the, these are the robots that have been deployed to date in the United States. You can see typically they're, with this one exception, this is a mine robot, they're very small. And in general, they're small because they're going places people can't go. Because if a person could do it, if there was a way to do it, we'd already do it. So this is adding new capability. And something I'm very proud, in the green is all the ones that the Center for Robot-Assisted Search and Rescue, of which I'm part of, has been there, that we have fielded scientific teams that have been able to insert technology and learn from those. All right, so those had all the modalities, but let's talk now about ground vehicles. So here's the Berkman Plaza 2 collapse last year, six-story parking garage. You don't need, the forensic structural engineers wanted this picture, but if you're a responder, you want to see what's underneath. And in particular, there were two places they wanted to see. One was right behind this hanging slab, which is incredibly unsafe. There was enough space for a person to get back there to look in, but it's just so clearly unsafe, nobody would get back there. And the responders will take a chance if they think it's reasonable. Okay, they will push, but they won't do it when it's suicidal. All right, so we put a robot back there to get back and look around there. And the reason why we're looking back there is because there was a report that a person had been up on this part when it collapsed, and so therefore he might be down here. Right, so you're using the information that you have about a collapse to modify your search and where you put your efforts in. Okay, but I'm not going to talk about that as much because we're going to talk about the survivor buddy. What would we do if we found someone? So out of all these 10 incidences, we've to date never found a survivor. We've found a lot of remains, but we've not been able to get to the right place at the right time to be helpful. But what would we do if we get there? So how do we do that? And here's just some of the stuff that we've been working on.
Rescuers want
and
it
this is
that
what we
way
initially
for the
started.
best possible test. The robot is on its way. The first challenge is to maneuver it by remote control through the rubble.
Very difficult to navigate and see. It's like looking through a soda straw.
When the robot finds me, rescuers need a good look and a conversation.
We want to know if you're okay, or where does it hurt?
I have pain in my left shoulder, and it's hard to breathe. I have pain in my left leg.
They need to see that the camera on the robot can get a good look at simulated injuries so that rescuers can triage, get help to the most seriously injured victims first. In this simulation, they've determined that my condition is stable.
Several rescue robots can be working the disaster scene at the same time. Another simulated disaster victim, Jamie, is now being contacted by a new generation of rescue robot.
Hello? Hello? Can you hear me?
In this simulation, she doesn't respond. Is she alive and unconscious, or has she passed away? If she's not alive, rescuers don't want to use valuable time that could be critical to saving other victims. This robot carries a kind of nose, a sensor that samples the air around the victim's mouth. When we breathe, we exhale carbon dioxide, or CO2.
The green here shows that there's enough CO2 to show that she's breathing.
A major breakthrough. They want robots. A tube on the robot can deliver water or even medicine. Through the hours or days it could take rescuers to dig down to the victim, the robot can be the only lifeline.
How to get them water, how to keep them psychologically comforted, talk to them, keep them motivated to. And I think what the person who's going to be trapped and found by a robot is going to be there for 4 to 10 hours. It will have been 12 hours statistically before we'll have found them. So this is going to be an important lifeline. But you can see our initial work 5 years ago was very, very focused on devices, the usual mechanical thing, you know? Right. And if you look and take the idea of a joint cognitive system from David Woods, if you know, we think about the robot here, there's a survivor. We've got a lot of work on how the mission specialist and the pilot, the person running the robot, you actually need two people, one to focus on the robot, the other person to look at the data and to interact with the person and stuff. And then with Eric Rasmussen, we begin to realize, no, this person, if you've got a crush injury or that, you're going to want to do some sort of reach back over a wireless network to the literally maybe 200 people in the world who are specialists in treating people in on-site care and how to assess and work with them. So you have this, and they'll be working with these, giving directions and telling what to do. And this might propagate on up. So this is a basic model of the larger cognitive system. We got in that. Now, if you think about human-robot interaction, right, you know, of course, how are you going to manage the victim? There's a robot, so there should be human-robot interaction. And the very traditional focus is to either work on this level, how we're seeing what we're seeing, or how these two groups are working together, the people behind the robot, and what should be made autonomous so that they can focus. Can you get rid of the pilot and just have the EMT somehow miraculously point in the right way and do that? And that's been the traditional focus. The problem with that is that we forgot, what about me, the survivor, with this thing in my face? In the dark, when I've been trapped for 12 hours and I'm in pain, and I now have a device in front of me, and that part needs some attention. And there's another aspect to it, is I'm now going through this device, I'm talking with people, I'm interacting with several people, and this doesn't even show the fact that sometimes we'll drive the robot off to go look at the disaster. You know, oh, hey, we're not paying attention to you anymore. I need to go look at this beam over here and do this and things. So we're not even talking about that. Already we have what's called a mediated experience. We're talking to people, but we're talking through this box. So that adds another level of complexity. And that brings us to Cliff Nass's work at Stanford. Byron Reeves and Cliff Nass did a breakthrough book on their studies called the media equation. And the equation, one equation, that's all you need to know. Media equals real life. He has all these studies that show if something moves, like on a screen, if it's got sufficient animacy, we subconsciously treat it as if it's animate. And we expect to respond to it socially. So that he's made a lot of great money consulting, doing things with call centers and how we find, you know, when the voice will say, I'm here to help, and you know it's not here to help because there's no I there. When do we accept I? When do we want it to be, you know, impersonal with that? So he does that with a media equation. And so we've got him involved in thinking about how people are going to react to these robots. And he had already predicted that people were going with these robots. Well, because they move, even if you heard your best friend on the other side talking to you, you would still treat this as this and that person separately. And I told him he was wrong. And it was about the third time I've told him, and I've just quit telling Cliff he's wrong because I keep having to buy him dinner. What we found with responders, they spontaneously, notice he's looking at the robot. He's looking at the robot, talking to it. He's maintaining good social distance. He makes eye contact. Before that robot was in there, that responder was using a hands-free mic. The robot came up, and it was a better two-way communication link. It actually had less static. So he began talking through it. He had no need to turn around. You would have thought he would have just done the way with the mic right here, just wherever he was looking at talk. But no, he would point to it, and they traded out operators. We still saw the same phenomena, that this entity was treated differently and treated socially. Interesting thing. So we've been working on following that up. Also, you've heard the stories about the soldiers getting attached to their bomb squad robots. And they're teleoperated. They're teleoperating the robot, but they still think of them as something discrete. It's very bizarre. and Cliff has all these studies that it's a different part of our brain. Okay, well, what does that mean for victim management? Well, it means that they're going to expect a social relationship. If they're not going to expect the robot to be in your face, they're not going to expect it to behave. We know that when people slow down, they don't get in your face, right? Based on culture, there's a certain standoff distance that's considered polite. When we talk, we make eye contact. That's a big cue to show that we're paying attention. They're going to, if the robot doesn't do these things, they will probably distrust the robot because it's not quite the part of the brain that's going, well, they should be behaving like an animal, they should be behaving like this, but they're not. They're, it's this stupid, why? And it doesn't matter what's coming with. All right, another one is that as that social actor is what Cliff calls it, this animacy. We begin to think of it as a social operator, which we've already seen. And then it becomes important that idea of the voice. Is it a synthetic voice? Is it a taped human voice? That could have quite a bit of impact. Think about call centers, and also whether it says I, whether that could also influence whether you trust, regardless of whether it's a doctor or structural engineer or just me talking over the robot, whether you trust it, whether you begin to get creepified by it. I don't think creepify is actually a word.
1, 2,
well,
3, 4.
Any Foo Fighters fans? Great. All right, so you know the story? You don't know the story. This is it. Okay, in 2006 in Tasmania, a gold mine collapsed. They were able to drill a hole to where found 2 miners alive. Okay, one of those things where it was going to be about 12 hours before they could dig them out. And so you're talking to them, you've got to line that, and they got tired of talking to the guys. They said, could you just send us down an iPod with the Foo Fighters? Right? And so, of course, Grohl heard about it, and he wrote them a ballad and had them, dedicated to them, the Ballad of the Beaconsfield Miners. Okay, so now let's take this idea that we've got this robot that's going to be up here with you. You're going to be attached to it, and we get into this idea of a survivor buddy. We're going to make it web enable it. Now, instead of just that creepy little robot coming in, a better behaved robot, but also fully web enabled. Now we can do the two-way video conferencing. Now Cliff maintains the first thing they're going to want to do is see CNN to be validated that they're part of a disaster, and this is kind of cool. Right? They're going to want music. They're going to want stuff. And how are they going to react to that? Because we already know that they react socially, and now we're putting this different part of the device, and we're being immediate. So this adds a problem in that we have what could be just normally a social actor. We would treat this, but we're also doing things like our CD player, which we don't relate to like a social actor. And if we mix it up, will it make people not trust the message? Going back to McLuhan, right? The media is the message. So what we've postulated is that in communications, it's fairly well accepted they're pure mediums. And there's a lot of support for the social actor work. But what we're postulating is there's a middle part, this social medium, which has a little bit of both. And that's going to require a slightly different configuration, slightly different heuristics on how we do it. And some ways that you would measure the congruence between, are you going to trust this device? Are you going to be comfortable with it? One is that does it behave well? Does it make the eye contact? Does it stay out of your face? Does it approach in the ways that we normally do? The communication identity and the voice. And in terms of affect, my NSF graduate fellow, Cindy Bethel, absolutely brilliant woman, has been looking at nonverbal and non-facial affect. So you notice these robots really don't have anything that looks like a face. Form has to be driven by function. We don't want any extra stuff. It's just one more thing that breaks. And so she went back and went through the cognitive and behavioral literature and figured out heuristics on how things behave based on distance, on proxemics. There's some cues that you talk louder when you're further away, but your voice automatically drops when you're closer because that would be rude to be yelling at a person, but further away they need to hear you. So she put all that together, and she's just completed a study. We're still working on the results, but this is partial results, where she has done over 128 people largest human-robot interaction, human subject study done to date. These are both real robots that we would use, that we have used in disasters. This is in a medical assessment path that we did for some original studies with doctors. So this is how they would drive the robot if left to their own devices. We captured 4 sets of video data. This was all done in the darkness. So those are night vision cameras because we wanted the people to feel trapped and confined and as stressed as we could be. And so here's the example of how we would drive it normally without thinking about, within consideration of the survivor. Bright lights, well, that was kind of jerky, you know, right at her face. The noise, we can't see what's going on. And you'll be shocked to see that people were creeped out by it. And that was on the self-assessment, they used the word creepy a lot. That's not helping. You know, clearly that's not. So why not we drive it or program it the way we do puppets to be more gentle, more consistent with nonverbal and non-facial affect. And so here you see, notice the lights are dimmed, it's submissive. We've got lighting so you can see more of it. It's no longer 2 dots coming like something out of the X-Files at your face, right? See him smiling and we all did physiological tests. So we've got all and she's going through all the stuff, but you could see the blood pressure and stuff, the different changes for people. So it's not just an assessment and individual bit. And so she's currently measuring the valence and the arousal and chunking through the statistical data here. But the initial work is that we're already seeing a strong indication that this is important. So that's what we've done. What we're working on now with the survivor is really to go into the Survivor Buddy project itself that's funded by Microsoft, is looking at communication identity. Is it I? Is it the robot? Is it I am acting on behalf? How do we phrase that? And Cliff Nass and Victoria Groom as grad students, the lead person on this. And the first phase is that we're doing this, we've just finished the script for this, and this is a video game simulation where the player is a victim, and they go to this video game and the robot comes through and it'll talk in one of the identities. This is the controller, is the pure medium, this is the robot, is the social social actor, and this one in the middle is, hey, I'm in that middle. I'm a thingy, but I'm also transmitting stuff I have no control over. Okay? And then apparently in psychology, the real trick with these studies, if people trust you, if you measure trust by giving them choices and seeing what they do. Do they take your suggestions? So we'll have a suggestion. Oh, people, at this point, the experts say that you should probably listen to music to calm down. Is that okay? And if they say yes, you know, then we know something. If they say, but you know, if they choose something else, that tells us something. And they have a series of questions in events within the scripted to go with that. And so if they take the suggestions, if they do the self-assessment and say they like the robot, if they show less anxiety in the way they respond, then we say that that identity is going to be more congruent, more leading to trust. And then we're building the Survivor Buddy. We've just found a really neat 7-inch monitor, a MIMO monitor that's a fully web-enabled. If you've seen it, it's pretty cool. It's got a video camera built in and speakers, microphone. And so we'll put that on top of our robots. We're building the heads for it now. And we'll take it out to Disaster City, where we've already done experiments with other aspects with victims. We have places where we can hide them in the dark and the cold, and with the spiders, I might add. So, and in future work, we've looked at non-anthropomorphic robots, but we'd like to compare that with anthropomorphic robots. And not just bipeds, but go ahead.
Just a question about the research. When you put the person in there, did you let them stay for a while before the robot came?
Now for the one that Cindy did, they had a 3-minute period of time before they got into the box. Then they had 3 minutes in the box so that their heartbeat would get down to normal. We would see, that. Also, it's also good to discover if they're going to be claustrophobic before, halfway through the study, ready to lose that point. So there were built-in things with that. Now, we did not try beyond that to do much more with anxiety, because if you've done human testing, they get really wonky about people, doing anything that stresses them out. In this case, in the previous case where we had, these were responders, subject matter experts. These are responders who wanted to play with the robots. And we have a whole nother study that came out of this. We were just going to try, it was for my human-robot interaction class, and we were trying a proto study. And we said, okay, we have an anthropomorphic robot that looks like a caterpillar or a snake. And we sent it down for them. And they said, well, that's creepy. Yeah, this is not going to work. And they also did something we had never thought of. Again, this is why I love field work, is that, so here we've got this $100,000 snake from Japan. And they just grab it and say, hey, look around. See, you can see, do you see me now? You see me now? Hey, look here. It was like, fortunately, the developer was right next to me, because I would have had a heart attack with that. If I was kind of like, but he was good because he was getting good data on how they spontaneously reacted. And that's another thing. Notice how we always think that victims are somehow just kind of, no, they've got their own agendas, they've got their own opinions, they've got their own life. I mean, and we just haven't thought of that. So even very surprising as we do these kind of tests. So did that? Okay, so the anthropomorphic, that was the example of the anthropomorphic. It doesn't always have to be, the usual Sony dogs or looking like an Asimov. We'd like to have this communication identity is really the first start to, like I said, we have medical doctors, we have structural specialists, we have people trying to talk to you as the victim that are just your friends and family. Now we have many people trying to use the robot at one time and communicate. How are we going to make that consistent? How is it not going to be confusing or overwhelming? And so we'd like to look at that as future work as well. And then we have one on communication voice. Do we want the synthetic voice? Do we want a tape human voice? Do we just want a facilitator's voice, a real facilitator's voice? And that we've submitted as part of a larger NSF grant. So just to summarize and wrap up, one of the cool things about this is the Survivor Buddy comes from both of our, we should take neat things that are in this sort of research space and apply it to an obvious need of victim management. But at the same time, we see the social networking, and those darn people just come up with their own ideas and trying to merge that to make it a web-enabled robot. And we're really looking at the mediation this way and focused on the social interaction that will happen because of the social actor, because of the animacy of the device with the survivor, yet we have it being the mediator to this larger world out there. And finally, to me, one of the coolest points, I love doing field work because I always get smarter. It always helps us identify new issues. And that's another strong suit of Texas A&M, is that we really trying to take advantage of our ability to work with the subject matter experts and insert and learn and continue that cycle, and to teach our students to be a little bit more hands-on. And it's just it takes a village. And here's some of the pictures of some of the teammates. Texas A&M, there's myself. Dr. Zornsis is working on building stuff for us from Double E, Cliff's group, and at University of South Florida we have Cindy Bethel and Jeff Craighead who've been working on this as well. So that's our group, and thank you so much for supporting this work. We're very excited about it, and we think it can lead to so much more. And it all started with y'all.
Thank you very much. you have time for questions?
Sure. My time's yours.
So you haven't talked at all about the robotic technical stuff. Is that kind of figured out? So do you feel confident about the ability of the robot to get where it should be?
I have never met a robot that I've liked yet. Okay, so there's certainly many things. But after 9/11, I wrote a series of papers and said, you know, the robots are okay. The biggest deficit is in the human-robot interaction. And in particular, I could show you, and did in my research, let's go back. I'm going wrong way, sorry. Yes. We focused right here. We could show you so many errors being made, slips and mistakes being made. And we saw lots of miscommunication that it took, that if you had one person run it, they couldn't do it because even if the robot still, you're in a deconstructed environment, you couldn't perceive it well enough. It's very hard to look through a soda straw. It's a keyhole effect. So we began working with perceptual psychologists and stuff. So I haven't hit on the robot. Well, first off, the robot mechanical stuff is a whole nother set of talks. We can talk about that. And I haven't really talked about autonomy because I want to talk about the HRI aspects of the survivor buddy. But I think the HRI is the biggest bang for the buck, the part, and particularly looking this way and this way rather than focusing on reducing the number of operators. A lot of people are doing that. We'll make some good progress on that. That's it. And I think, yeah.
At a certain level, though, isn't something better than nothing? Like if I'm trapped in the dark, if something comes down, it's like, okay, at least I'm not forgotten and I know. Then after that, then these factors come into play? We've
heard debates either way from the medical doctors. We've heard debates either way from the medical doctors that, you know, you could be so in shock and in pain that it just sends you over if it's super creepy, okay? What's interesting to them and to the psychologist is that, you know, so for the first 15 minutes this is great, and then you don't trust the robot anymore. You don't take directions coming from it. You don't do it. You ignore it. And we're talking about managing over a 10-hour period. So what does it cost to explore that, to get that benefit? Right. And
I have a question about your experiment setup for either your anthropomorphic or otherwise robots. Did you tell your participants, I mean, obviously you tell them, hey, you're going to be in close space or whatnot, I assume.
Yeah.
Do you tell them to expect to encounter a robot, or do they have any idea?
I forget, I do not recall the exact form that Cindy did, but we said, oh, you're going to be working with rescue robots.
Okay, so they know somehow a robot's going to be involved.
They know somehow a robot's going to be involved.
Would there be any plans to kind of leave them in the dark?
We could look at doing that for some of our field trials that we're looking at doing on another thing. You wind up into some interesting problems with the IRB until you get further along. They don't like for you to like, yeah, those kind of big surprises. At Texas A&M, we have a big volunteer program. A lot of people come out on the weekends, like, you know, the Boy Scouts and Girl Scouts can get their community service and stuff by being victims for the dogs, to train the dogs, right? You know, you put people in those rubble piles. They have two of our 8 rubble piles are built specifically for you to be sitting there forever. You know, like you've got room for you and a soft drink and something to snack on. Because, you wait for the dogs to find you, which could be a long time because some of them are young and not too sharp yet, you know. So we'll have volunteers so we can look at doing that, yeah. And I want to do it. I like the total immersion because you really, really get those impacts.
So I was wondering how you would simulate a situation where the victim is seriously injured and you want to probably test out how they are reacting to maybe an anthropomorphic robot. So whether it's creepy versus something that's not so creepy.
Well, there are different ways to induce stress and anxiety that don't require physical pain. There's techniques where they have you do very frustrating problems and you get the same physiological response. So and then you just imagine doing that and being in the dark and being confined and being uncomfortable, but not in any way dangerous or health, but just kind of that and that whole thing. And then say that. So the psychologists have ways of doing that. They've studied how to do it without like actually hurting. Now, of course, you never know until somebody's out there, and that's why working with medical professionals who have actually done this on site, and there are very few, relatively few, that have that kind of experience. One of the things we draw on very heavily off of Eric Rasmussen's experiences in Turkey and the Turkey earthquake. So.
You said you just started work with the display panel, right? So you're going to be able to show things on there, particularly people's faces. I mean, there's obviously been work done that you can show pictures to people and they see when they recognize there's immediate rush of dopamines or whatever because they love. That should have some calming effect, right?
You would think, and also we know that certain music has calming effects, right? And so you can sometimes regulate a patient's heartbeats by the music you play in the background. So there's a whole bunch of that. An interesting thing about heavy metal, but when you do an MRI or something, when they put you in there, you get to pick your radio station now and stuff. People are very savvy about this. But what we also expect to have happen is that the two-way audio video may be there, but we may not tell the families. They can see their families, but the families can't see them for fear that they're going to overreact. Because people tend to look a lot worse than they actually are, in those situations. And so it's a whole, it's like, it's gone from, what do we do if we find somebody, which apparently the strategy for the emergency response world is that Robin, being the chattiest robotics person, will be stuck talking to this person to the, we'll do web, oh shoot, there's some serious psychological ramifications. Yeah, and we're trying to figure out ways, again, something's better than nothing, but let's try to do it as right as we can, given that there's this wealth of wonderful ideas from psychology and communications theory.
I was also thinking, though, that if you see a human face, as opposed to, being anthropomorphic about the robot, like this one's actually got a face on it, albeit it's a video screen.
They're going to they're going to treat it as a face, as soon as they see that. Yeah. We try, look at sock puppets. We managed to get a face out of a sock puppet. It's like we see faces in cars. We're wired to do that. So yeah. So we expect there's that.
But on that note, building on that, what about going to more fully animate light bulb, something that was more biologically, capable?
Well, that's what we'd like to look to in some of our future work, because we are getting, so you like where I'm going here. The two robots I wish I had the most of, that I had, would be one that looks like a scorpion. The legs are wonderful, and then you use that tail with your camera to get up the height that you need, which gives you, all right, that's anthropomorphic, but creepy. All right. And the other one is a ferret. Yes, the face-eating ferrets, right? Because ferrets are leg snakes, right? They get up, they can look around, they squeeze through places. What a beautiful set of agility. Again, something that we're not really, wanting in our face. So, and then, let's do the small cockroaches. Case Western, Roger Quinn has some lovely things. They can wigs, they can stick, they can climb, but they're cockroaches. Oh, now I've got 10 creepy things coming at me with not enough light or power for me to really see and visualize. And we think one of the important things is that if you can see it, it will be better. And also the sound, so that we'll start overriding some of the this is creepy animacy stuff. So we'd like to go there. I think there's a huge thing. And then of course there's the more benign anthropomorphic designs.
Dave Turetsky's got that really nice scary spider.
There are so many creepy things. Dennis Hong has one. He says, "Look at this," and it's like, "You go, Dennis. You go, boy. That's going to work really well. You just have people like stepping on it. Just so." But it's interesting how we react. We would have never, we did not, I've been doing emergency response since 1995 and doing field work since 1999. And it just is fascinating how wrong I can be, and just all the things that we're learning. And it's not often not the technology, it's how we use it, how we package it, how we present it, how we help people train and the silly things. And so that's why I love being in the field, is to try to get that insight.
Sneak one more actually segues from what you were just talking about. There is nothing wrong with this field. I find it fascinating, this particular application domain. But what about other application domains of potentially this research in, for example, in home robotics or assisted devices? Do you see your research being able to speak to those contexts as well? Have you done some thinking there?
Well, we think it's going to be heavily related to healthcare has been looking at as projecting the healthcare provider there. But now what do you think about somebody who is highly dependent on robots, or a robot, a shut-in who is interacting as their media to the outside world? I mean, that's the thing they talk to. I mean, that's how they talk to other people, really. And that we haven't seen looked at in healthcare, and we believe this type of work will carry over to that as well. Okay, so that's anytime that you have your connection to the world is mediated by a robot for a long period of time, where you have a real dependency, not just that 15 minutes initially, or when something comes through, or as an interrupt, but as a continuous thing. We think that this will have significant impact and help, if not help frame the answers, it will help frame the questions that need to be answered.
Thank you.
Great. Well, thanks. Thank you very much for having me here.